A rational expression is an algebraic expression that can be written as a ratio. Do you remember what a rational number was? Basically, you think a rational number is like a fraction. So anything that can be written as a fraction is a rational expression. So rational expressions cannot contain roots of variables or variables as powers, such as this. So equivalent rational expressions. So you can write basically a fraction infinite number of ways. 2/3, if I multiply 2/3 by 4, I get 8/12. If I multiply it by 5, I get 10/15. If I multiply it by, 10, I get 20/30, etc., etc. So same thing I can do to a rational expression that has x's in it. You can multiply it by 2, but you got to watch, you got to multiply everything by 2. So 2x minus 10 over 2x. You can multiply it by 3, 3x minus 15 over 3x, etc., etc. So, non-permissibles. Which one of the following are non-permissibles? Well, can you divide 0 divided by 5? Yes, you can. You can get 0. Can you divide 5 divided by 0? No, this is a big no-no. This is undefined. Can you go 0 divided by m? Yes, 0. What about m divided by 0? Undefined. Going back to the previous one, 0 divided by m, as long as m is not a 0, of course, that would be the only way. 0 divided by x minus 3 is 0, provided that x doesn't equal 3. And x minus 3 divided by 0, of course, is undefined. So the biggest thing you got to worry about is you cannot have a denominator that equals 0, because the value of the expression would be then undefined. Any value that gives the result is called a non-permissible value. Non-permissible values should always be stated with the answer. So I'm not going to ask you to state it. You need to actually state it. The non-permissible value must be found before simplifying. So you got to ask yourself, what will make the denominator 0? Well, if x was 0, that would make the whole thing 0. Or if y is 0, that would make the whole thing 0. So if you can't see what k can't be, set it equal to 0 and solve. So 2k minus 5 equals 0. Actually, it doesn't equal 0. So 2k, move the 5 over, can't equal 5. So k cannot equal 5 over 2. Most people can do this mental math way. So for instance, the next one, b can't be. Well, if you put 0 in there, you'd get 0 at the bottom, because 0 times anything is 0. So b can't be 0. And if you put -6 in for the b in the second factor, you would get a 0 out of that. Now sometimes you have to factor. So this is what? X plus 6 times, a plus 6 times a minus 1. So that means a cannot equal -6 and +1. Again, what I'm doing is I'm setting the factors equal to 0 and solving. Non-permissible values can be found by inspection. That's more like the mental math, just looking at it. Setting the denominator equal to 0 and solving, or factoring and setting each factor equal to 0 and solving. To simplify a rational expression, it's usually necessary to factor. You're going to be doing lots of factoring in this unit. The numerator, the denominator, or sometimes both. This will usually give a form of 1 that can be reduced. So you're looking for things that you can cancel. A rational expression is in the simplest form or lowest form when the numerator and the denominator have no more factors other than 1. Simplify the following rational expression. Factor the numerator and the denominator. State the non-permissibles. Cancel. The top. Okay, so maybe we should do this in order. So let's factor the numerator and denominator. There's nothing really you can factor 2 times x, I guess. And then you can factor out a GCF, x times x plus 1. So now you can see this, and you can say that x can't equal 0 and negative 1. So because this is a monomial x and this is a monomial x, we can actually cancel that form of 1. Remember, you're looking for forms of 1 that you can be canceled. So then this is equal to 2 over x plus 1, where x cannot equal 0 or negative 1. Okay, let's try the next one. The next one, we need to factor both the numerator and the denominator. So what would that be factored to be? X plus 5, x minus 2 over x plus 3, x plus 5, yes? So at that point, I can see the denominator, x cannot equal negative 3. I don't know why I put a comma. Negative 3 and negative 5. So do you see the form of 1? X plus 5 over x plus 5. So I cancel. So then my final answer is x minus 2 over x plus 3, where x cannot equal negative 3 and negative 5. Okay, so let's do some practice now. Why don't you you can pause the video and try to go ahead. So we'll factor out a 3a. We're left with 2a plus 3. Because I know I want to factor out a 3a, I'm going to factor out a 3a here. So then I'm left with a 4a. Do you see there's my form of 1 I can cancel? And then I'm left with 2a plus 3 over 4a. And I need to state my non-permissibles. A cannot equal 0 in both a and the other a in the denominator. So watch, there's a lot of times people will try to even cancel more. They think the 2 and the 4 can be reduced. But the problem is the 2a is attached to the 3. And so in order to do any kind of canceling, it has to be a form of 1. And 2a plus 3 would have to be with another binomial for that to happen. So you can see here d cannot equal 0 and c cannot equal 0. Okay, so now you can look at this separately. Do you see that this is negative 18 over 10 times d to the power 5 over d to the power 7 times c to the power 4 over c? So do you see this fraction can be reduced to negative 9 over 5. This fraction can be reduced. You can use the exponent laws and subtract. However, I know that there's going to be more d's on the bottom, so I might as well just go and put the 2 d's that remain on the bottom. Now for the c's, I can see that there's going to be, if I subtract 4, subtract 1, I can see that there's going to be 3 c's left, and that, of course, goes on top. So then, comma, d and c cannot equal 0. Okay, moving on, we need to factor. So that would be 2x minus 3, 2x minus 3 over 2x minus 3, 2x plus 3. And you can see my form of 1 right there. So 2x minus 3 over 2x plus 3 is my final answer. But I got to say x comma x cannot equal. So there's 2 spots where it can equal 0. So set 2x minus 3 equal to 0. Move the 3 over, divide by 2. I get positive 3 over 2. This one right here, move the 3 over by subtracting 3, and then dividing by 2, I get minus 3 over 2. Next one, we can factor. So that would be 2d plus 5, d minus 3 over 4d. I'll give you a little hint when you're factoring. You know something's going to eventually cancel. So if you're having trouble finding factors, look for common factors that are on the top or the bottom. For instance, because the top had d minus 3, I suspect that there would have been a d minus 3 in there. So that makes it easier to solve. So the d minus 3 cancels. So you get 2d plus 5 over 4d minus 1, where d cannot equal, remember it's both factors. You got to look at that, right? So that is, move the 1 over, divide by 4, I get 1/4, and then positive 3. Moving on, we have a common factor of 5 we can factor out, and we're left with y minus 3. So again, now that I know there's a y minus 3, there's probably going to be a y minus 3 on the bottom that it's going to cancel. So how am I going to make this work? Oh, look at that, y minus 5. And so those cancel, and I'm left with 5 over y minus 5. Again, y cannot equal both factors, 3 and 5. Again, watch. Although you're very tempted to cancel those 5s, you cannot do that because y minus 5 is attached together. It will only cancel with another y minus 5. Okay, moving on. So this is f minus 4 times f minus 4. So now here's the thing. If I factor this is the difference of squares. So that would be 4 plus f times 4 minus f. So now you look at this and you think, well, wait a second, there's nothing I can cancel because they're similar, but they're not exactly the same. So I'll show you a little trick. I call it the -1 trick. And so if you see one that's very similar, for instance, these two right here, if I were to factor out a negative out of that one, do you see I would get the top one? So for instance, if I factor out a -1, what would I get there? Well, I would get -4 plus f, which is the same thing as negative bracket f minus 4. So do you see there, now I can get the f minus 4's to cancel. Now watch, there's a negative there. So that means I'm going to get f minus 4 over negative bracket f plus 4, sorry, 4 plus f. That negative, because it's going to this whole bottom, you can also stick it in front like this, negative bracket, sorry, negative f minus 4 over f plus 4. I'm going to write it that way. You could also write it as negative bracket f minus 4 over f plus 4, like that. As long as you have one negative and it's going to the whole thing, it's all good. Okay, so I still have to state my non-permissibles. F cannot equal, if I look at the bottom, it can't be negative f and, sorry, negative 4 and positive 4. Okay.